Okay, now I want to use this software to verify my result. So first, I want to change the function into sine of x. And the interval here is from 0 to pi over 4. Now, pi over 4 is around 0.79. So, so I move this point to 0, and I move the upper bound to 0 to what number? 0.79. 70. Okay, that's 78. So we can see the result is 0.37. The average value is around 0.37. Is this equals 0.37? So square root of 2 divided by 2, and now 1 minus square root of 2 over 2 equals this, and we multiply this by 4 over pi. Now the result is 0.3729, which is close to this. Okay, so the last thing in this lecture is the mean value theorem for integrals. So the result is if a function is continuous on the closed interval AB, then there exists a point C in the open interval AB such that the function at C equals the average value of the function. So what this means is if a function is continuous, then we can guarantee that between A and B, we can find a point like here. That point is probably is here. We can find a point, and the function value at this point will be equal to this average value. So in our graph, the point is here, is C, because the function value at C is this, which equals the average value. Okay, so why this is true? Remember in the previous lecture, I think in lecture 20, we started the mean value theorem. So the result is suppose a function is continuous on the closed interval and differentiable on the open interval, then there exists a point on the open interval such that the derivative of the function at this point C equals f of b minus f of a over b minus a. Okay. So right now I just changed this. I just write this using the capital F. So that mean value theorem tells us capital F, the derivative of capital F at C equals f of b minus f of a over b minus a, right? And here we know so here capital F is our accumulation function. So the definition is equals the integral from a to x little fx. Okay, and we know if we take the derivative of capital F, we will get the little f, right? And since the derivative of capital Fx is little fx, therefore the derivative of capital F of c, that will be the little f of c. Okay, so this term is f of little c. And on the right hand side, according to the first fundamental theorem of calculus, the difference between capital F of B and the capital F of A, that is equal to the integral from a to b f of x dx. So this term, the numerator, is equal to this. Okay, so that's why f of c equals the integral from a to b fx dx divided by b minus a, which we can write as 1 over b minus a times this integral, which is the average value of the function. Okay. Just like when we studied another mean value theorem, we said one of the application is to find the point C, right? Is to find the point C such that this is true. So for the mean value theorem of integral, we also have a similar problem. We have the same type of problem. Sorry. So we want to find the point C at which the function value equals its average value on the interval from 0 to 3. So what this means is we're given a function and we're given a closed interval, and we want to find where is this point such that the function value at this point equals this average value. Okay. So to do this, first we need to know what is this average value. First, we need to calculate what this is, and we can do this by using the definition of the average value function. So since the average value of function equals 1 over b minus a times the integral from a to b fx dx. Therefore, it equals 1 over 3 minus 0 times the integral from 0 to 3, 2x minus 6 times dx, okay, which equals 1/3 times the integral from 2x minus 6 dx. Okay. To use the first fundamental theorem of calculus, we need to know what is the antiderivative of this function. So we start solving for this indefinite integral, and we can do this by using the property. So we can write this as 2 times x times the integral of x and minus the integral of 6 dx. Okay, so then we have 2 times x times the 2 times the integral of x dx minus the 6 times the integral of x to the 0 dx. So then we can use the power rule to find the antiderivative for each integral. So this is 2 times x squared over 2 minus 6 times x, which is x squared minus 6x. Okay, since the antiderivative of the function 2x minus 6 is x squared minus 6x. So this definite integral it equals x squared minus 6x, where x is from 0 to 3. Okay. So we continue from here. When x equals 3, this is 9 minus 18. When x is 0, that is 0. So this is 1 over 3 times negative 9, which equals negative 3. Okay. So the average value of the function equals negative 3. Okay, then we want to solve the equation. We want to solve the equation for c, which means we're looking for 2 times which number minus, because the function is a 2x minus 6. So we want to find 2 times which number minus 6 equals negative 3. So 2c equals 3. So c equals 3 over 2. So for this function, when x equals 3 over 2, the function value will equal the average value. Okay. Let's verify this result using this same software. So now my function is a 2x minus 3. So 2x minus 6. And the interval is from 0 to 3. Okay. So we can see that the average value is negative 3, just like what we find here. And so when x equals this number, when x equals, let me see if I can make this bigger. When x equals this number, the function value equals negative 3, and this number is 1.5, which is 3 over 2. Okay. Let's see. Let's see if I can. All right. Right. When x equals this number, 1.5.